Hello everyone, welcome back to the channel. In the last video, I shared the system design of the audio visualizer app. In this video, I will walk through specific files in the application source code and explain how the files are connected to create the application. The files we will go through today will be the main C++ file, the audio visualizer C++ and header file, the scene manager and scene registry header files. So how are these files connected? The audio visualizer class is instantiated in the main C++ file. Then the start method is called to start the application. And that's done for the main class, the main C++ file. In the audio visualizer header file, we have a default constructor and destructor methods. The load window method creates the application window, and start audio visualizer method contains the application loop. So let's move to the audio visualizer C++ file and see what this two function does. Before we do that, let's talk about the private first. So in the private section of the audio visualizer class, we have attributes that store the window dimension and window title. There are two uninitialized attributes that store scene ID and window information later that will be used later in the application. So in the audio visualizer C++ file, the load window and start audio visualizer methods are defined. The load window method uses the window attributes defined in the private section of the audio visualizer class to create a window. The window attribute is an object of the render window class. The application window is created using a virtual function in the render window class, which takes window mode, window title, and the style as parameters. Now let's move to the start audio visualizer method. In the start audio visualizer method, the load window method is called. Then the scene manager object is instantiated. As long as the app is not closed, the while loop continues running, and under the while loop there is a second while loop that handles three system events, which are closing the window, mouse button release and left click, and mouse movement. And under each event, there are specific actions that occur if those events are true. So if the window is closed, it will close the window. If a mouse button is released and mouse left button is clicked, it will perform this action. And if the mouse moves, it will perform this action as well. After the second while loop, the window is cleared with a specific color provided by the scene manager. Then there is a check for loading the next scene, otherwise the current scene is rendered and displayed to the window. If you have not already noticed, the scene manager is in charge of what is displayed to the window. The main responsibility of the scene manager is to load the scenes and render the scene to the window, And when we're done with the scene, it will unload the scenes and delete it. Now let's move to the scene manager header file. In the scene manager header file, we have the scene manager class. And this class have a lot of methods, but today we will be talking about the constructor, we will talk about the destructor, and other two methods that we will talk about will be the set scene and the load scene methods. Before we go into that, let's look at the private section of this scene manager class. In the private section of the scene manager class, we have scenes attributes, which is a hash map that contains scene name as a key and scene object as a value. Then we have a string vector scene IDs that contains all the scene names. After that, we have current scene pointer, which is a pointer of scene class that points to scene object. And lastly, we have scene ID that stores the last scene ID. And we have the file path, which stores the file directory of a music file. In the public section of the scene manager class, when the class object is instantiated, the constructor calls the setScene method, then loads the upload music scene, which is the first scene name in the scene ID's vector. After that, we will move to the setScene method. What the setScene method does is it sets all the scenes for the scene manager class object. It does this by traversing the scene ID's vector and passing each scene ID as a key to store scene objects in the scene's hash map. To do this, it calls this static method from scene registry class. If we take a look at the scene registry class, we can see it has a default constructor and a default destructor, and it has a static method which returns a scene object. And as you can see, it returns different scene objects based on the name of the scene. And the reason we have this different scene object is because this scene object are derived class of the scene base class. So we have a scene class and upload music, visualization are based our derived classes of those of the scene class. Now we move to the load scene method. So the load scene method takes scene ID and window as parameters. First, it assigns the current scene pointer a scene object, and the last scene ID a scene ID. Then it checks if the current scene was properly set before proceeding to load the scene to the window. As you can see, it checks if the current scene is a null pointer. If it's a null pointer, it means that the scene was not properly set. So it throws an error if that occurs. Otherwise, it just loads the scene. Then we have additional conditional blocks here that check specific scene. If it's a process audio scene, then it retrieves the file path for that specific scene. So we have the same thing for visualization. So if the scene ID is equal to visualization, it would first get the file path, then would give that as a parameter to this scene method. Finally, we will move to the destructor. So what does the destructor do? The destructor deletes the current scene pointer and calls the unload scene method, which deletes all the scenes in the scene hash map. Yeah, to just summarize everything, the main C++ file starts the application by calling the audio visualizer class. Then the audio visualizer header file and C++ file implements the application loop. And the scene manager manages all the scenes that are displayed to the window. So far in this project, I have implemented a music player which can play any music format that is supported by SFML music class. And the next feature that I will be trying to implement would be to visualize those the audio wave to the screen. So if you're interested in that, keep watching and you will see that soon. I will provide the source code of this entire application on GitHub, and I will provide the link in the description below. So, if you like this video, please subscribe and thank you for watching.